Hey everyone, once again, here's lecture 5 on the drawing environments, different types of drawing environments that we can do in LaTeX. We're going to go through, this is kind of more extensive than some of the others, so bear with me on this one. It may go a little longer than I expect. But anyway, let's jump into it. So in the preamble, we're going to learn about two different drawing packages. One's called the Tikz package, and that's the one that's kind of used quite often to like draw different shapes or pictures, if you will, or graphs. And PGFplots is primarily used to do drawing graphs, such as things on a Cartesian plane and things of that nature. So those things allow us to do that, and we're going to make use of that. One important thing about this package, this drawing environments, is that you can also import images that are already like PNG, JPEG files, PDF files that are images into your document. We'll do that later in this. It's very important that wherever you store your LaTeX file at, so you notice over here for me, I'm working on lecture 5 drawing, and then I have a PNG called Mario and a PDF called Trippy. Those have to be in the same folder, my lectures folder, as my LaTeX file is, in order for it to find them. So you get like a blank image in those places where you do it. In the past, and the reason my preamble looks kind of muddled here is because I have this thing called a graphics path. Now, I don't usually use Overleaf when I do my LaTeX. I have LaTeX downloaded to my computer, and this here is set up to pull images directly from a specific path. If I want to do that, that's an option you have when you're using LaTeX on your desktop rather than online like we do with Overleaf. But you also have the same, on your desktop, you also have the same kind of scenario as we do in Overleaf. As long as you put the images in the same file or same folder that you're putting your LaTeX file in, it will find it and be able to pull it. So you may not need this graphics path. So this is not necessary for you guys here as long as you put your images inside the folder that you're currently working with. Best way to do that for when you start doing the Lab 5 for this, you will have some images given to you in there with the PDF LaTeX file that you have to mimic, and those images, just save them to your desktop and then upload them into your folder. Okay. So anyway, let's get going here. So drawing shapes using the Tikz package is definitely a useful thing to know how to do, and I actually like the challenge of it a little bit. All right. It's not always easy to get what you want out of it, but if you keep trying, you can kind of get what you want. Very similar to the table environment, there are some PC free software out there. I'm blanking on the name of them right now, but if you just Google search LaTeX drawing software or whatever, you might find some of these different packages where you can draw pictures like in a paint type environment, and it will write the LaTeX code for you. I have found that those don't always work well, and you still have to make fixes within the stuff. So I'm going to refrain from doing that. I want you guys to try to do things from code as well. I won't ask you to do anything I haven't shown in here anyway, so you should be able to be good to go here. There's many ways to get our drawing or an image into LaTeX. We'll start with the Tikz package. All right, so the first part of our PDF, all this stuff is done in Tikz. So over here in my document, below those first worded sections, we can simply draw lines, lines and shapes using the Tikz package. All right, so for example, drawing a line segment is a pretty simple thing to do. We just use the \draw command, like so. So notice I began and did a begin and end center, and also did what I call a begin and end Tikz picture. And inside of that, I said draw, and these brackets here will fill stuff into that later. That's a place where we can, in the square brackets, you can set things up like to change the color of something or change the thickness of it, things like that. To draw a simple line segment, it's just like on a coordinate plane. You have to imagine your Tikz picture is on a piece of graph paper. And so if we go from 0, 0, dash dash 7 comma 0 is the coordinates, and it draws this first line that you see up here in between the draw command like so and the sentence that begins. We can add another note or statement. So that first line is just that simple line. We can also add words to a picture, all right, and they call these nodes. So I'm looking right here at this line 32, and I did a no indent. Not that that matters that much for this, but to add a node, I simply just redrew my picture, my line from 00 to 70, and right below it, I put node. Some description of the node usually goes in the first little, in these parentheses. Not everybody uses this, so sometimes you can leave these blank, but if you want to keep tab of what your nodes are when you're drawing a difficult picture, it helps to know, you know, to kind of give some kind of description of your node. That will not show up on your PDF. You say at, and then you say the coordinates for where you want it to be at, and I played around with mine until they were centered. And then in curly braces, I put, look, I made a note using a node, ha, and so it put it right above it. All right. You can also have it put it below it, but you just have to change your coordinates in the XY coordinates here, and it will do that. All right. It's nothing crazy there. We can also change the thickness of our lines, which is what I've done in the next little segment after this sentence here. We can change the thickness of the line segment by inputting words. Thick, very thick, are using the input line width equals some measurement. All right, so I did all three of these in different pictures, Tikz pictures. And the first one I centered it again between begin and end center. Began and end my Tikz pick. And I drew the line thick, put the thick command in the square braces, and then still made the same thickness. And I did a node, and I named it thick so that I remember that's what it was, even though I'm named it over here. It's just one of those weird little things. And put it at the midpoint of that line segment, just a little bit above it. And notice that when I do a node, I have to end with a semicolon. That's how you know that you're done with that part of that node, and it goes with the previous line. So it's important that you end these things, and we'll see that in a minute when we do some other ones that have more than one line in the same picture. So that was my thick line. I did the same thing for very thick. The only difference is I wrote the word very thick in here, and it made my line a little thicker. And then I did the node to reflect that. Again, ended it with a semicolon. Last but not least, the third line where it says line width equals 2 point, I quite literally, after the draw command, in the square brackets, put line width equals 2 point. Now, I like the line width equals option better than I like thick and very thick, because you have more say-so on how thick your lines are. I mean, you can set this thing to be as thick as you want. We could set it to be 20 point, and it'd be ridiculously thick. Let's see what it does when I recompile. It takes this kind of stuff when you have drawings a little longer to compile, but it made it a lot thicker. So you have a lot more options here with how thick your lines are when you're drawing, when you use the line width command. All right, and most of the drawing commands or type commands in Tikz or PGFplots will let you use this line width command to kind of tell how thick you want things to be. We can draw several images or lines or items in one Tikz picture like we did here. It's kind of whatever you put between the begin and end Tikz picture. You can do several of them in a row. As a matter of fact, I could have done the thick, very thick line width equals 2 point just above these colored lines here in the same manner. But I wanted to set them apart at first. So I did a begin center, end center like I did before. You don't always have to do begin, end center. But most often we do want our pictures centered on page. And then I've got a begin and end Tikz picture here. In between that, I've drawn every one of those lines. So I had it draw a line width equals 1 point, for the which automatically, if you don't put a color inside this box, it automatically assumes it's black. And I went from 0, 0 up to 0, 4. So it went vertical this time. And then I did a node, and I rotated the node 90 degrees to go the same direction as the line. and at -5, 2, called it black, comma 1 point. That's how I got the black 1 point right here. And then I just kind of kept drawing. I did draw a blue line, made that a little thicker, 2 points, from 1, 0 to 1, 4. So I skipped over a little bit, and then I put a node in there for that one, rotated at 90. If you don't put black here, it will automatically change it to the blue that you've designated the drawing line to be. So you have to be aware of that. But notice I ended that with a semicolon, just as I did the previous one. It means I can draw the next picture. Draw a red line, width equals 3 point. And so forth and so on. So you're seeing what I'm doing. All I did was keep drawing a thicker line each time, line width 4, 5, 6, 8, 15 point, and went and changed the colors on each one of them. These are stock colors in LaTeX. And then I made the nodes fit accordingly. So the way that a Tikz picture does is it's kind of like if you've ever used a if you ever tried to put images on top of each other in a Word file, and they give you the option to arrange those things, it's going to arrange them however you put them. So if you want something on top of something else, you have to watch the order in which you put things in, because it will quite literally put the first thing down first and then draw the second thing on top of that, the third thing on top of that. So these I had spaced out. It wasn't an issue, but sometimes that can be an issue. So be careful of that. You can change the line from a standard solids and add arrows to the ends if you want. The standard arrows can be used by doing the following. Right here, a double lined arrow like this, just a less than, minus, greater than symbol, and that'll put just regular arrows at the end of it. But you have other options too, and that goes in the square bracket when you're defining, just like your line width does. These things go inside your brackets as well as the colors. Anything you want your line to have reflected at the end when it draws it is what you want to put here. So look at the different arrows types I have here, and these aren't the only ones. There's other ones with different packages and stuff. Special arrowheads require the use of the arrows package, which I did put in the preamble above. Somewhere. Where did I put my arrows package? Right here. Use Tikz library, and this is something new too. The arrows is part of a library instead of a package itself, and so to use certain things, sometimes you'll be recommended to use a certain library to get certain shapes and things of that nature. If anybody's doing any graph theoretical stuff, I have some examples of graph theory graphs drawn in nice, neat little templates that you probably could utilize when you do your presentation later in the semester as well. So back to the arrow types we have. So notice my first. I've done this kind of sort of backwards. I went from 0, 0 to 7, 0 and draw my first line with just regular arrows. And that's this arrow at the bottom. So it drew that first. And then I put, that's the standard arrows. I put that node there and ended it with a semicolon. And then I drew another one, pretty much almost the same, except for I put the word stealth and stealth at the end of it. And that gives these nifty little, they're kind of hard to see, so I'll blow it up a little bit. But it gives these neat little stealthy looking arrows at the end. And the other thing I did was I wrote the word dashed in there. And I went, instead of going down or side to side like I did with my colored lines above, I went and put this at 0, 1 to 7, 1. So I just went up 1. So I'm building it up. As we go down this list, I'm building the different arrowheads and line types as we go up. The third one I did with a parenthesis on either end of the minus sign. And that gives you like parenthetical arrows. And then I did a dotted instead of a dashed line. So right here, parenthetical arrows. And then for this fourth one above that, I did line width equals 2 point. If you do star on either side, you get these circles, or they're like points. And then I did that one called dash dotted, so it's like dash dot, dash dot, dash dot. Of course, I put the node after that. And then some of the specialized, some other arrows that you can do, you can also play with the simple arrow setup, where if you put double arrows on either side, or double less than, double greater than on either side, it will do double arrowheads on either side. That sometimes comes in handy. And that's just a solid line. We didn't do anything funky there. And then last but not least, you can also do special arrowheads that look like they're facing a specific direction. So I did a greater than, minus greater than here to get the arrowheads to go in that direction. If I switched them around the other way, they would obviously go the other way. So if I did, instead of greater than, I did less than, then, and recompiled it, it should flip it around. So pay attention to the order things go in, because it will make a difference. Specifically, you'll see this a little bit later when we draw a picture on top of itself. So let me minimize this back out a little bit, get the page all up there. And let's go to the second page. So on my next page down, we're going to see how you can draw different shapes. So creating shapes is as easy as connecting dots or knowing something about your shape that you desire to draw. So circles are actually the easiest thing to do. We're going to talk about them specifically. So circles can be created by using the draw command. After the draw, you tell the program where you wish your center of the circle to be, your XY coordinate input, and the word circle, and in parentheses you input your desired radius. So for this first circle here, I did a begin and center as I've been doing. Begin in Tikz picture, I did a simple draw a line width equals 2 points. I made my line width 2 point thickness, and I set the center at 0, 0 on my drawing pad, if you will, and did circle after that, and then did 2, so the radius is 2. So that's it. Simple. Circles are pretty simple to get. Rectangles can be drawn a couple of different ways, but there is a rectangle command. So squares and rectangles are pretty simple as well. These two, the square and the rectangle I have below here, basically what the Tikz picture does is it asks you to set the bottom corner of your square or rectangle somewhere, and then write the word rectangle, or type the word rectangle, and then put your upper corner over here. So it bases it on the 2 coordinates for these corners here. So in the first square there, the orange square I have, of course set orange, line width equals 3 point, made a little thicker. Sometimes the brighter colors look better when it's a thicker line. And did 0, 0 for the bottom corner and 2, 2 at the top to make a nice square. So that's a nifty thing that you can do. And the same thing with the rectangle. It just depends on where you set that upper corner at. And so here I put it at the coordinates 4, 2 for that red rectangle over here, and it did just that. There are a lot of things I probably won't cover that the Tikz package is capable of doing and drawing, but that's one way that you can draw rectangles and circles pretty simply. Triangles are not always as easy, and other shapes aren't as easy. There are some functions that will draw them. I'm not going to go into them here, but if you need to draw hexagons or some other kind of specialized shape, you can do that. So this is where the connect the dot kind of feature kind of comes into play. So we're looking at this gray triangle here and this pentagon that's purple. And so over here I did fill equals gray to get my fill of my shape to be gray, and then I did line width equals 2 points. Again, same thing. Begin, center, end center, begin Tikz, end Tikz, and in between the Tikz picture, begin and end, we put the stuff. And instead of telling it to draw a rectangle or a circle or just draw a single line, you can connect the dots. So I started out at 0, 0, went over to 5, 0, up to 5, 4, and 0, 0. Notice I have a dash dash in between each one of those that tells Tikz to draw the line to connect those dots. And so I connected it from the beginning point and then cycled back around to it. Sometimes they call this a cycle. And there is a command called a cycle command that you can sometimes use for these kind of things as well. The pentagon I did pretty much the same way. I just had to get kind of creative with where I put my coordinates. I would never expect you, when you're recreating something, to know exactly how to do that, so I will try to tell you what coordinates are best for that in those situations. When you're doing your own thing, it's kind of whatever you feel works for you. And just for giggles here, the third one down here I have on the next new page, on page 3, is just me showing you can get as creative as you want with your images. There's nothing to keep you from being able to do that. And in this case, I did something a little bit different, some new commands in between the square brackets. I did red. Now notice I didn't say it's not fill equals red, it's just red, which makes the border red. The fill equals blue, and I did this exclamation 40. What that does is acts like a hue setting. So if I just did straight up blue, took the exclamation 40 out, it should make it a darker blue. And it did. So doing the exclamation and then a number between 0 and 100 will kind of lighten the color, if you will, so you have some control over how dark your blue or green or whatever color you might use is. It's kind of like an opaqueness setting. The closer to 0 you get, the more opaque it is, and the closer to 100 you get, the darker it is. Alright. Let's check out this next picture here. Nice good old right triangle. The words adjacent, opposite, and hypotenuse. That's where I started this picture right here. And I drew the triangle first. And so I did line width equals 2 point and then connected the dots like we've seen before. And then I started putting the nodes in. So I've got the node for hypotenuse at 2, 2. And had the word hypotenuse put in there. Notice I didn't put a semicolon after this. I waited on that until I had all the nodes I wanted. And then I did a node for the adjacent side. And you kind of have to play where you put it, and it's pretty easy to do. You can kind of get it set how you want it. I think hypotenuse and adjacent might be a little closer than I like. I did an opposite side, and then I did a theta in the angle right here for the probably what is the 30-degree angle, and put the theta symbol in there and placed it as close to that point as I could where it was still visible. And then I did a semicolon. Alright, so when you're drawing things like this, semicolons are your friend. I don't believe we did do semicolons after we're done drawing. So when you're done drawing something and you put all the nodes you want, you definitely want your semicolon there. I may have misspoke before. Alright, now I had to get a little bit creative because I wanted to draw the box in the corner here, and there's no nifty little tool to draw the right angle box. And so I had to play with that a little bit, and I drew a little line width from 4.6 comma 0.4 to 5 comma 0.4. So that drew the line right here, the top line in the little 90-degree box. And then I did 4.6 comma 0. I don't know why I have a point in there. And then 4.6 to 0.4 to draw the connecting line up this way. And then to get this little blue arrow, angled arrow in here, there's a new command here for you. You can make lines arc if you want. If you do a draw. And then I did just a dash greater than to get my arrow going in one direction. It sometimes takes playing with this a little bit. I made my line width 1 point and made the color blue. I had it start at 1.25, 0. The coordinates is where it starts here at the bottom of the triangle. And then I had the word arc. And in the arc, what I do is tell it how far I want it to arc. So I did an arc from 0 to 30 degrees. So 0, colon, 30 degrees, colon. 1.25 tells me basically where I'm starting at. I want it to kind of go up and angle back that way. So you can kind of play with that a little bit if you ever have to do it. You won't have to do much of that, but sometimes you need to use that. I got a little fancy here in this next one, and this is one where I was talking about it. You have to watch the order and how you draw things. There's no nodes in this one per se, but I have several circles and curved arrows going amongst the circles inside a gray box. So the first thing I drew in blue with a blue outline was the square. So I did a blue, line width equals 2 point, fill equals gray, and I did %40 to make it a little lighter. And I told it where I want the bottom angle of it to be, and I went negative 4.1 to 4.1 to 4.1 to 4.1. So my grid, basically, if you will, or if I was drawing on a graph paper on a coordinate plane, I've got a nice even thing centered at 0. So I can get it helped me out put the circles where I needed them to be. And then I drew the fill blue circle here in the middle with the %30 to kind of make that a lighter shade as well. And I centered it at 0, 0 and did a circle, a radius of 2. And then to get these next ones placed where they need to be at is utilize the fact of where the circle's at and what your radius needs to be to connect them. So it's kind of like figuring it out as you go. It's kind of like a math problem, which is what I kind of enjoy about drawing in this. Not everybody does. But I made the red circle up here, or the pinkish colored circle, but I did that by doing red %30 right here inside this next draw. Set the center at 0, 3, so 0 and 3 up, and then made my radius 1 so I knew it would touch the big circle in the middle. And then I did the same kind of thing for the green circle below, the orange circle to the right, and the violet circle to the left. Alright, so that made that kind of simple, but they're all being placed on top of that square in the back. Next I had to get those weird angled arrowheads. And so I did the dash greater than in there inside the square brackets to get that. Made my line with 2 point and colored them red. And I started the first one at the coordinates 1 and 3. So for here we go over 1 and then up 3. So it's the start of this arrow going down from the pinkish colored circle. 2, 3, 1. I gave the end coordinate over here as 3, 1. So whenever 1, 2, 3, and up 1. And they gave the command 2 in between. Sorry, 2 in between. And then said out 0. So it comes straight out of the red and in at a 90-degree angle at the bottom. So this is one way you can kind of, no matter how large or how far apart things are, you can kind of say go out from this thing and in at a different angle degree, and it will angle it accordingly. So I had to do that all the way around for each one of those things to get the rest of them. Anyway, I'm not going to have you do anything quite this difficult, but it's nice to know you can do it. So let's talk about PGFplots for a minute. The PGFplots is the mechanism we use to draw nice graphs. I would use what I'm giving you in here as a template if I ask you to draw one of these things, and you can change the little things, because this is kind of like on and off switches in here. You can change all the settings within the Tikz picture with the PGFplots. So for this first one here, I wanted to create a Cartesian graph using the PGFplot axis properties. And so the whole setup at the beginning, this is all the axis properties. I'll go through those in a second. Made the minimum -5 and the max 5 for the x min and x max, and then I made the y min and y max the same thing. So I'm going 5 ticks from the origin every direction. To make sure, and I'll show you how to make sure your tick marks are marked correctly in a minute. Let's just go through the code and show how we made this first graph. So this graph, we were trying to plot the function f of x equals 3/4 x squared minus 3/2 x minus 9/4. And so I set the height and width of my Tikz picture there. And we'll zoom in on that a little bit so it's easier to see. Let's move it over here. Alright, and so that's an 8 by 8 centimeter picture, so you can change the height and width however you like. I like them to be square because they look better that way. I set my X-min and X-max, Y-min and Y-max from -5 to 5 for the X-min max, and -5 to 5 for the Y-min and Y-max. The axis lines are set to equal. You probably shouldn't change that. That's something that's pretty normal. Axis on top equals false. That tells you that's like a bypass. If you set it to true, it's going to put that gray axis on top of everything. I'm pretty sure that's what that does if I'm remembering correctly. Let's see. Yeah, but it's hard to tell. Yeah, you can tell through this we're unhighlighted in yellow here where it changed and it looks like it's setting on top. It doesn't look as good, so probably always better off leaving that grid to false. That's a good default setting for that. Grid equals both means that it's going to do both the X and the Y grid lines. The minor X tick number is telling how many units you want it to go, so it's going by ones. The minor Y tick label is going by ones. You can also experiment with this. So if I did this by 0.5 here, instead for the minor X tick mark, it should probably give us some extra tick marks in there. Yeah, notice how the grid changed. So the minor X tick number is putting the ticks on every half-inch line. Excuse me, every half-inch line instead of every whole number line. But I don't like the way that looks either, so I'm going to change that back to 1. You can set your major and minor tick lengths, and that's the length of each tick mark on the actual picture. And so you kind of want to leave those short because you don't want them sticking out too far anyway. So we've got them set to 0.15 centimeters for the major and 0.075 centimeters, so half that size for the halfway marks. The tick label style, font equals tiny. That controls the basic font overall on your numbers that are your numbering, and the X and Y labels give you your X here and your Y up here. And then you have your on and off switches here for your minor grids and major grids. So if they're all set to true, you see them all. If you turn any of them to false, like let's set the Y minor grids and the Y major grids to false, just so we can see what happens. And when we compile it, it should take them away. And it did. It took all the Y grid away, which kind of looks neat, but unnecessary in our case. Alright, so let's put that back to where it was. Last but not least, or last two but not least, you've got your X tick, your Y tick, and your X tick, which is how you set it up, how you want it to count. So if you want it to count every 1, then you go -4, -5, -4, ... to 5, and it will give a label on every tick mark that you have. If you wanted to skip every other one, then you could literally go -4. We'll just do this with the Y tick. The Y ticks -4, -2, all the way up to 4 like this. And if I recompile that, on the Y-axis we should only see the even numbers marked, which again, not necessary in this case, but no, it's good to know you can change it however you want. So we'll keep those the same. And then you can, the tick style is semi-thick, color equals black. If you want to change the color of your tick marks, you're more than welcome to. In some cases, you might want to do that. And then finally, but not least, last but not least, after we've defined our axis the way we want it, we need to draw our actual function. And so we do this using the \add plot command. The first thing I drew was this little red coordinate for the vertex down here, and I said draw equals red, the mark equals star, which makes it a circle. We made it very thick, and we filled it in red as well, so it made it all red. The coordinates are 1 and -3 for this guy. Alright, so I had that plotted, then I ended it with a semicolon. Next, I actually wanted to produce the actual curve, the parabola there. And so I did add plot plus. This means add on top. And I defined a domain of my function. So I said I wanted my domain to be graphed from -2 to 4. So -2:4. Mark equals none. You don't need anything special there. Draw equals black, even though we don't really need that there. It'll draw it in black automatically. We made it very thick. We did arrowheads on both sides, so that produced the arrowheads on the both ends of the curve. And I did samples equals 200. The reason I do this is because the more samples you take, the smoother your curve is going to look. So samples of 200 are pretty good. That's why sometimes it takes this a little longer to compile, because it's having to draw that image. And then I put the function in there that I wanted to graph. So I kind of simplified my function that I gave you guys up here and put it in vertex form. Okay. And you don't have to put this in between math symbols, but you do have to put math operators in places, so be cautious of that. So look, I put 0.75, and I used the star above the 8 key for multiplication, and then in parentheses I did x minus 1 squared minus 3. So you have to be cautious and make sure, because if I took this star out of there, it doesn't behave like your calculators do and knows to multiply that. You have to actually tell it to do so. So if I do this, I should get an error or something weird. It still drew it, but it didn't draw it the way I wanted to. So apparently Overleaf does something a little differently. But if I put that multiplication back in there, it will do it a little bit better. Let's see here what it did. It went between -0.5 and -1, so it shifted it a little bit too. So it treated it differently. Okay. And then I have a node at axis coordinate system is what the CS stands for, 2, -4. And that node is this whole little box thing I did down here. So I did a color box, which we learned back from the text environment of yellow. And in that is supposed to be, it's colored blue, although it's hard to see on this screen. And I did what they call footnote size. And then I put my actual function that we saw above here in the paragraph in there, so I could label it. So that's, you can label them. You don't have to do it with the colored box, but you know, there's different ways to do that. Okay, and so one other thing I want you to note here is we did a begin and end center before we started all this. We have a begin and end Tikz picture before we started this. We also have to have a begin and end axis. So my recommendation to you is, when you have to reproduce one of these for me, just use this as your template and change the things you need to change to make the graph look accordingly. Okay, the things up here in the axis, if the axis labels are different, make sure you can do that. Make sure that you can put your that you define your add plot function correctly in any coordinates you have, which you can do multiple of these. I think we can probably, if I wanted to add another one on there just for giggles, I think I could put a comma in parentheses here and do, let's say we wanted to put one at -4, 1. This may or may not work. I haven't tried it in a minute. It's doing something. Nope, it didn't like that one. So I needed to have another one for the separate coordinate. Because it did not like that. Sometimes it does and sometimes it doesn't. Sometimes you have to put several of these in a row, unfortunately, if you want more like points on your graph. Here we got a little fancy with the cosine and sine and tangent functions. So I'll let you guys kind of look through this, but my cosine of x function I had to get a little bit fancy with the labels and stuff like that to get the pies and everything in there. So you'll see that I made my height 5 and my width 13 because I wanted it to kind of be sprawled out in my after begin axis here. Then I set my x-min and x-max to 2 pi, negative 2 pi to 2 pi. My y-min and y-max at negative 1.5 to 1.5. Axis lines in the middle only, so I didn't put them. I didn't want it looked too busy when they were at the halfway marks or the half tick marks. Axis on top, we left that the same we did. Grid equals both. I took that out because I could define where I wanted my grid to be down bottom a little bit easier. My numbering system's still 1-to-1 for my minor ticks. All right. My major tick lengths are at 0.5 and 0.075, so that didn't really change. We didn't have to change that. So the only other things we had to change here were turning off the minor grids for the x and y axis. And then we put the x ticks. I actually had to put them in as a series of the values of pi. So that's how for my x ticks I got negative pi over negative 2 pi, which is and you can just give it a really approximated number. Negative 3 pi over 2, negative pi over 2. 0 is going to be there no matter what, and pi over 2, and then goes so forth and so on. Now the labels on that x-axis, the x-tick labels, is another place I had to get creative. And so I actually had to, in the math and little money symbols here, I had to actually put in the negative 2 / pi to get the negative 2 pi symbol to show up. Negative fraction 3 pi over 2, and so forth and so on. So these are not always easy to deal with, but I will say they do look pretty good when you're done with them, and the effort is sometimes worth it. All right, so I've done one of these for cosine, sine, and tangent. You can kind of look over those to see what I did. The other thing that I added to this was a legend. I didn't have to really do much for the legend because the legend automatically knows what line you're plotting. And so for this one, I just did legend position and said outer equals northeast. So I put it to the north and to the east side of the graph and put a little line in there and said cosine of x. How does it know to do that? Well, down below here, after we plot the actual line, we put legend and put what we want to go in the legend. The add plot function here, it actually will do the cosine point for point for you and graph that. So I went from -7 to 7 to kind of go off the ends of my graph a little bit, to be a little bit larger than the negative 2 pi value. And then I drew it with a teal color. Line width equals 2 point. Again, I did samples equals 200. This time I function for trigonometric functions. LaTeX will not know if you just put cosine of x in there. It won't know how to do that because it'll do something a little weird and funky. So in your cosine, within the parentheses after your cosine, you have to put degree of x. So it knows to take the degree of the x values and convert those into the points that you have along the curve. Other than that, that's pretty much it for the cosine, sine, and tan. I just wanted to show you that there were other options, and these are just other examples for you. So I'll skip over the sine and tangent and not talk to you about those like crazy. Here's another one I did. How about one more in standard -10 to 10 x and y axis with a node? The node can be placed placed anywhere you like using the @axis CS and then entering the coordinates after that command. We saw that a little earlier. That's this one here on line, starting on line 381. Notice I kind of went back to my original picture height and width here after the when I'm defining my axis, an 8 by 8 centimeter. My x-min and y-min are both -10. My x-max and y-max are both 10. So now I'm going to have 10 tick marks across the entire thing. All right. Axis lines, I've got middle, axis on top, false, grid both ways. Everything else is set up pretty much the same until we get to the X tick, Y tick definitions. Notice I did -10, comma, -8, comma, .. 10 for both the X tick and Y tick definitions. And that just meant along my Y-axis here, it only labels every even tick label here. 2, 4, 6, 8, 10. And the ones in between are your 1, 2, 3, your odd numbers. Here I added plot, and I had to do the domain a little funky because this is a cubic. And I drew it blue. Did the same kind of setup, and then I put my actual function in there. You can actually draw the function out like this as well. And then did a colon, and then I did a node at axis CX 3.5, -9. I did a color red, script size, and then in math type I did the display style that you see down here, f of x equals 0.45 x squared plus 2x blow it up a little bit for you, sorry about that, plus 2x squared minus 3x minus 7. And so we get that picture, we get that at the bottom, and we can place that anywhere we want as long as we use that command node and then do at, and in the parentheses here axis CS colon, and put your coordinates right afterwards. Okay, so not too bad, it's just a little bit finicky when you're first learning to use it. Alright, we're almost there. Now we want to, so we can also draw, create, or just grab image files from outside of LaTeX and import them into LaTeX using what they call the include graphics command. The images can be, like I said earlier, JPEG, PNG files, EPS files, or PDF files, just to name a few. Sometimes PDF files can be a little bit wonky, and EPS files can definitely be a little bit wonky if you've never been familiar with those, but there's ways to work around that. There's some things you can put in your preamble to help out with that. I recommend staying with the PNG, JPEG, or PDF files, though. And you don't have to do this whole create a folder thing like I did earlier. Like I said at the beginning of the lecture, put your images in the same folder as your LaTeX file, and it will find them. You just have to know the name of the file. Okay, so let's look at how we do this. All right, so I'm coming down here to line 424, and I begin and end center. All right, and I include graphics. Height equals 2.5 inch, width equals 2.5 inches. So I kept it square. You can alter that as you like or need to do. And I had this command keep aspect ratio true. So I don't really need both of these commands in here. But if I take this keep aspect ratio out of here or set it to false, then I can change the width and height of them to be contrast rather than be the same. So you can kind of play around with that to get your picture to stay on task. So all that stuff goes in square brackets right after include graphics. And then in curly braces, you put the actual name of the file, picture file you want it to actually pull from. So I've got a mario.png. Called it just like that as it is over here in my folder, my lectures folder, and it placed this Mario right here. The only difference between this first Mario and the second Mario, and the reason I kept them in the same begin and end center, was, and I did one right after the other, so they stayed pretty much on the same line. As long as you put one after the other, sometimes you can get things to stay on the same line. Other times you have to get a little more creative. So if I back up here, notice I'm right there. It really wouldn't matter. This just looks messier. But if I keep them side by side or line to line, so it's not going to really make a difference. If I give a space between them, it's going to end up putting it on a different line, most likely. So if you want them side by side, keep the lines of code together, one on top of the other. Because if I do this, it should theoretically shift him down to the next page, which I don't want. So recompile that guy. And to get that second Mario, once this recompiles, there we go. So the second Mario here is starting to do a backflip. And so the way I made him look like he's doing a backflip is I angled that same picture I had before at a 45-degree angle and still used the same Mario, so everything was the same. All I did was add the in the square brackets. I added the little command angle equals 45, and it made him angle 45. And then on the next page down here, I kept that up and did a include graphics. I'll probably do the space here. I did a different little way of doing this because the pictures are a little bit wider going one way than the other. I don't think I need the multiculls, but I did it anyway. Let's find out if I do. Undo that. What the heck just happened? What the heck just happened? Okay, that was weird. I've never seen that happen before. Anyway, I'm going to percent out the multiculls and in multiculls and recompile it and see what happens here. Notice I have a space between both pictures of Mario, the one where he's looking straight up and the one where he's looking straight down. So it did put them one on top of the other. Let's see if I pin them side by side if I get the same thing. So it still didn't put them on the same line. So the multiculls is actually useful here when you have an image that's too big to be on the same line. Also, I wanted to use the column sep rule and give that a divider line between the two images. Apparently it wants me to do the space here. Sorry for the slowdown here, folks. And are we back to normal? We're back to normal, okay. So I had to put that space in there to keep them that way, and because I'm using multiculls, it puts them in both separate places. But notice the only thing different I did with the include graphics command here, everything is the same as the first two Marios on the previous page, with the exception as I made my third Mario a 90-degree angle, and I did my last Mario at a 270-degree angle. Imagine if we made him smaller, we could make it look like he was doing an entire flip in like some kind of weird motion. Maybe we'll try that in a second. You can also place your graphic in a figure environment, which will allow you to input a caption. All right. The figure environment works a lot like the table environment, where we had to put the H, where I showed you guys in the last lecture, we had to put here because you want the image to go here, and the exclamation mark, which kind of ignores the floating, and we'll put it right where you want, the image right where you want it. And I can do a centering command to center the whole image. Here I did include graphics. I set the height and width to 7 by 10. Keep aspect ratio true. Which once again is probably ignoring this height equals 7 inch. Because I kept the command keep aspect ratio true in there. If I set it to false, it'll probably change the size of it a little bit. Let's see. Compiling. Compiled, and no longer is it where I want it to be. Yes, it did something weird. So when I set it to false, it kind of elongated it and took that width being 10 inches into consideration. So it probably doesn't need to be that big. So if we say true here, it's probably only paying attention to the width there. So the width probably needs to be by 7 inches as well, if we kept this as false. And hopefully that'll put it back on the same line. It didn't put it on the same line, but so sometimes you have to play around with these things. That's my point here. If I put true in here again, it should move it back back where we had it on the page. And it did. For some reason I have it angled at 90 degrees. I'm not sure why I did that ahead of time. That's probably because it was set to where it's probably shifted these two big green and blue black circles. Here we're probably down at the maybe not. Let's see. Let's see if that's even necessary. I can tell you what it probably most likely was me copying and pasting it down there and leaving it in place. And what do we do here? Is it going to look any different? It moved it down because it's the same thing, but for some reason when I had equals 90 in there, it kept it on the same page. So graphics can be a little bit weird in the way they behave. Oh, good lord, I just did something really weird. Angle equals 90, there we go. For some reason, having angle equals 90 in there put it on the same page as I had on the last page, like I wanted it to be. So sometimes just playing around with these things to get them where you want them to be is helpful. Probably changing this height and width in here would have made it a little bit of a benefit to us. But nonetheless, after that include graphics, we did we imported trippy.pdf because it's the one over here. It doesn't have a preview for me, but that's okay. All right, and I wanted a caption below it. So this figure environment allows us to use the \caption command. So if you want captions below, it will number them accordingly, like figure 1 here. And this says, does this image mess with your vision a bit? And so I could put that in curly brackets, and it shows up below the actual image. I'm sure if I did this again, it's going to shift it to the next page anyway, but it should theoretically label the figure as figure 2 if it's working the way it's supposed to work. Let's find out. Recompile, compile, and this one's down here and it does it. Labeled it figure 2. So we'll label your figures when you use the figure command. If you're just drawing a simple picture and you don't want it to be captioned, you don't need the figure below it. You don't need to use the begin end figure environment. That's only for when you want to have a caption down below. There are other ways to caption things as well, but this is one of the ones that's most widely used. That is it, folks. So you'll have like I said, you'll have a lab 5 for this that you'll have to try to get some pictures to show up for me. I'll recreate the PDF as you see it, and then the next week we'll utilize all the tools you've learned so far for your midterm. I'll talk more about that or send out an announcement more about that later. So get to know this environment a little bit, and again, use these tech files I'm giving you with all these examples in them use some of this stuff as templates. Don't start things from scratch. You don't have to. It's not always necessary. Sometimes you can start with what you have and kind of fiddle with it till it does what you want it to do. I will be doing 2 more videos. They will not have labs associated with them. One for the Beamer, how to use Beamer in LaTeX, which is the PowerPoint version for LaTeX, which you'll need big time to do your presentations, and also the poster environment. So I'll probably be doing 2 videos for that, but don't worry about watching those until after you've done the midterm. I'll post those sometime soon. So anyway, take care everybody. Talk to you soon.